Hello students, once again welcome to our channel physidive, and today we are going to study a very good and important topic in class 11 NCERT: accuracy, precision and errors. And here we'll just go one by one and see what are the different things, what are the different aspects we need to study here. And this is your teacher alexirajan, so we'll dive straight to the class. The first term that which we are going to study is nothing but accuracy. What do you mean by accuracy? You all know in our daily life we used to say that thing. You should be accurate in your deeds, in your things, which you are doing in a day-to-day life. So, but you need to know in terms of physics, in the language of physics, what do you mean by accuracy? We are studying the chapter measurement, units and measurements, right? They're all, we are using different techniques to measure different physical quantities. For example, if I want to measure a length here, then what will I do? Definitely I will take one scale or ruler, and then I will measure using the different readings marked on the scale, right? So you know all these things. If I want to take, in olden times there were mass weighing pans, so there are weighing pans there. So if you want to measure some mass, then you will put some weights there, and then you will measure the things in other pan, and you will see that thing. Okay, this, if they are staying in a stable straight line, then you can say the weight is equal to this much, right? Mass is equal to this much, not weight, mass. And if you want to measure some time period, then you will have a watch in your hand, then definitely you will have certain timings there marked on the watch, and you will see the time, and you can say the time is 10:10 right now. If it is morning, then it's AM. If it is evening or night time, then it's PM. So you all know this particular basic things. But for example, for simple instance, I'm saying, what is time now? What is the time now? If the actual time is 10:13, 10:13 or something, right? But if your friends are asking you what is the time, then definitely you will say it is 10:10, or sometimes you will say it is 10:15. 10:15. But is it true? No, it is not true. The accurate time is 10:13. But still you say it is 10:15 or 10:10 for your convenience. So what do you mean by that? Here, accurate time means it is 10:13. That is how close you are to the true value. For example, if one of your friends if the actual time is 10:13, and if one of your friends is saying that the actual time is 10:10, and another friend is saying that it is 10:14, it is 10:14, then who is more accurate? Who is more accurate? You will say that thing, this particular friend is more accurate. He is more accurate, right? He is more accurate. Why? Because this 10:14 is almost near to 10:13, which is the actual time. But this 10:10 is also right, but still there is a small difference. That is, this number or this time is much more closer to 10:13 than this 10:10. So here comes the actual meaning of accuracy. How close you are to the true value. This is what the accuracy states. In physics, in laboratory, you have a particular instrument called as vernier calipers, which we use to measure the thickness of a sphere, thickness of a cube and all. There, what we used to do is that we will not stop. Okay, if I want to just measure the thickness, then I will not stop by taking a single value. For example, if x1 is the first reading which I got, I will not stop it there. Why? I know that thing, this is not the true value. What I want to do is that there will be some errors somewhere there that we are going to study right now. But what we are going to do is that we will take 2 to 3 values again. So x2 will be my next reading, x3 will be my next reading, x4 will be my next reading, like that. At least 3 reading, minimum of 3 readings should be taken while you are taking a reading of thickness or any physical quantity. Then what we are going to do is that we'll take the average and that average will be the true value. For example, x is my average, then x1 plus x2 plus x3 plus x4 by total number of reading, that is 4. This will be my true value, right? So we'll see which particular value is closer, whether it is x1 or x2 or x3 or x4 is closer to this particular true value. Then the closest one, the closer one will be the accurate value. This is all about accuracy. I hope that you got the point there. Sometimes in nowadays, if you're dealing with quantum physics, then the timings will be not in seconds, it will be in microseconds. So that much accurate the values you are getting. You will not, the time taken by this particular photon to reach in the other place is this much seconds. No, it won't work. You need much more accurate, much more precise. I said the next word, that is precise, right? What do you mean by precise? Right now we'll learn. So I hope that you got the point about accuracy. Now the next word that which we want to study is the precision. Precision means the extent or limit to which a physical quantity is measured. How much extent you are measuring a particular physical quantity. For example, if you are saying that a man is moving from one point, let us say A to B. The man has reached to this particular point B. Now you are saying the time taken by this particular man is 10 minutes. Like this. Let this be hours, this is minute, and this is second. Right? Now I am saying that more precisely, I must say that thing. The man has walked 10 minutes, 10 seconds. So the timing will be 00 hours, 10 minutes, 10 seconds. That means you are precisely saying that this much extent I had measured the person's movement. This says that how much extent or limit I had measured the time, right? This is what I'm saying. For example, if I'm saying the length of this particular line is 2 centimeters, then another person is saying that it is not actually 2, it is only an approximation. I am saying that this is 2.2 centimeters. Then who is precise? The second one is precise, right? If another person is extending some more accuracy, he is putting some more precision into this thing, then I will say, or the person is using some more better instrument which is having high resolution, high resolving power. So I am saying a resolving power of 0.01. Then he is saying that this particular line is 2.23 centimeter. Here all you can say that thing they are approximately equal. With your naked eyes, you can say that thing everything is equal, 2 or 2.2 or 2.23. All the three are equal. But in the first case, the precision is what? Up to 2. That particular instrument cannot measure more than that. So more precisely, I am using the second case and I am saying that, okay, I am using another instrument which is having a resolution of 0.01 centimeter. Then I will say it is 2.2, right? Then I am saying it's not centimeter, it's millimeter, right? So the another thing, the third one is at 2.23 centimeter, right? So that means it is having a precision of 0.0. Okay, this one, 0.01 millimeter. That means I am just increasing my extent or limit of my measurement of this particular length. Then I can say the more precision is the third one. This is more precise, or the precision of the third length is more than the second and the third. So this is about the precision. Now we are moving to the next topic, that is the errors. Now seeing the errors. In the beginning itself I had said we have seen accuracy and we have seen precision. And we have also learned about the true value, because in laboratory or in any experiment, whether it's in physics or chemistry, we use a set of readings there, and then we use to find out its average, and they will say that it is a true value. True value is nothing but the average of those readings. Average. We'll say if I am just having X reading, then X bar will be my true value. You understood? And then you will say that thing, this is my true value, and these were my readings, X2, X3, X4. And I will say that I will just observe whether what is my difference. What is my difference? That is, with this particular, with respect to this true value, how much it is deviated from the true value. Errors are of two types. First one is systematic, and the second one is random errors. So we'll see one by one. Systematic errors means the first and foremost thing is instrumental error. If you're using an instrument, which is so old, then you can see that thing after each year by year, slowly it will show some sort of errors. That means you will not get an accurate value used to due to this wear and tear, due to certain other technical issues, due to certain other mechanical parts, wearing of certain mechanical parts and all. You will not get the correct value. So here, obviously, some errors can happen. So this type of errors due to the instruments problem is known as what? Instrumental errors. Second systematic error is due to certain procedural errors. That means for each experiment, we have to do certain procedures, correct procedures. Then only you will come across a correct answer. For example, in a simple pendulum, we have to find out the simple harmonic motion. Then if you take a simple pendulum here, and if you oscillate the simple pendulum with higher amplitude, then definitely you will come with the wrong answer. In simple pendulum, make sure that you have to cut short your amplitude to a small amplitude, so that almost a straight line should be satisfied, or the oscillation should be in a straight line. Amplitude should be small. But somehow, if you see a simple pendulum, there is a tendency that you will just push or pull that particular bow, and then you will release, and then it will move like this, move like this, move like this, and then you will come across slow, wrong. So this is what happening. That's a procedural error. You should not do that thing. Each and every experiment have certain procedures, and you should follow those procedures. Then definitely you will have a correct answer. So there the errors will be lowered, or errors can be curbed there. Next thing is the personal error. So personal error, as the name suggests, it is due to the carelessness of a person. Sometimes the errors can happen. In chemistry also, due to titration and all, if you are just titrating certain solutions, if you are careless, then definitely you will come across wrong answers. Same way, if, for example, in the simple pendulum case itself, if you want to find out, if you are taking the readings of the time period, if you're taking the reading of time period, and you will definitely use a clock there, which is having certain readings, and then you will stop clock. There is one switch there, and that switch, if you are pressing that switch, then definitely it will stop. Sometimes what happens is, due to that particular over excitement, what you will do is that before the reading gets completed, you just stop the clock or the watch. Then you will not get the correct timing of the oscillation. Sometimes due to carelessness, this can occur. And sometimes if you are taking the reading of the length, what you will do is that instead of taking the measurement in a straight eyesight, what you will do is that you will just measure it from another angle. Then definitely what happens? Due to that particular angulation difference, you will get it wrong. The fourth one is natural errors. We used to take measurements, or we used to do experiments using this simple the semiconductor. In semiconductor case and certain experiments, we have to maintain certain pressure, certain temperature. So if there is a variation in temperature or pressure, then definitely what will happen? Then definitely you will get a wrong answer there. While conducting experiments using Ohm's law, then the temperature is a very important factor. So definitely, if the temperature is varying if there is a huge difference, then definitely you will get a wrong answer. Wrong answer means errors will be there. Your answers will get deviated from the true value. Then errors will occur. So that is about the natural errors due to nature's reason or the natural condition variation. Errors can occur, and we say it's a natural error. So that's all about the systematic error. Now coming to the random errors, it is unknown. It can be any reason. It's not known properly, and that is known as what? Random, unknown reason. So that's all about errors. So that's all for today's class, and we need your support. Like, share, and subscribe the channel. We'll see you in the next class with new topic, that is errors, more precise, and we'll just study a detailed case of errors. What are the different types of errors? How we can mathematically prove and all. So we'll see you in the next class. So take care. Goodbye.